Good morning, students. Now, this is the last topic, residue arithmetic in that fourth unit. Now, it's a demo topic. నేను ఎవరికొకరికి ఇస్తాను ఈ 2 daysలో మీరు ఒకసారి డెమో ఇవ్వండి దెన్ ఐ విల్ కంటిన్యూ ఓకే జస్ట్ 1.5 పేజ్ ఆర్ 2 పేజ్ వదిలిపెట్టి నెక్స్ట్ యూనిట్ కంటిన్యూ చేద్దాం you have to leave only 2 pages for this one. This is the last topic, residue arithmetic. It's a demo topic, very easy topic, right? Now next one we are going to move to third unit, right? Third unit is generating functions and sequence and recurrence relations, right? Now so these are the introduction basic part, right? Please go through these formulas, right? If you want to solve the problems you have to by heart all these formulas, right? Now introduction. A sequence is nothing but what? A sequence is a function from set of natural number to real numbers or real numbers to natural numbers, right? A sequence is a function from set of natural numbers to real numbers, right? Now say example, Sn is equal to, suppose one sequence is given to you, Sn is equal to n square, right? Sn is equal to n square. When n is equal to 1, what will get? S1 is equal to 1 whole square, that is 1. When n is equal to 2, what will get? S2 is equal to 2 whole square, that is 4. When n is equal to 3, S3 is equal to 3 whole square, that is 9. Therefore the sequence Sn is given by, what is the first term in the sequence? 1. Second term is 4. Third term is 9. Fourth term is 16. Fifth term is 25 and so on. This is the sequence, okay? This is the nth term. Sn is equal to n square. It is defined by, the sequence is defined by Sn is equal to n square. When n is equal to 1, I got S1 is equal to 1 whole square. When n is equal to 2, S2 is equal to 2 whole square. When n is equal to 3, S3 is equal to 3 whole square, like that. That means what is S1, what are S1, S2, S3 and so on. All these called terms of the sequence. First term in the sequence, second term in the sequence, third term in the sequence and so on, right? Therefore the sequence is 1 comma 4 comma 9 comma 16 comma 25 and so on. Similarly, here a simple sequence is given to you, that is denoted by A, right? A is equal to 2 power n, where r running from 0 to infinity. That means when r is equal to 0, what will get? 2 power 0. 2, when r is equal to 1, 2 power 1. When r is equal to 2, 2 power 2. When r is equal to 3, 2 power 3 and so on. These are the terms of the given sequence, that is denoted by here A. 2 power 0, 2 power 1, 2 power 2, 2 power 3 and so on, right? Now 2 power 0 is 1, 2 power 1 is 2, 2 square is 4, 2 power cube is 8 and so on. This is the terms of the sequence. Similarly, another sequence is given by the sequence B is equal to BR r running from 0 to infinity, where some restrictions are there. BR is equal to 0 if 0 less than or equal to or less than or equal to 4. 2 if r 5 less than or equal to or less than or equal to 8. 3 if 8 less than or less than or equal to 10. Next 4 if r is greater than 10. Now some conditions are given. When r is equal to 0, b0. When r is equal to 1, b1. When r is equal to 2, b2. When r is equal to 3, b3. When r is equal to 4, b4. When r is equal to 5, b5 and so on, no? Right, that means r running from 0 to infinity and so on. But b0 value, br value is what? Is 0 if r lies in between 0 and 4. Yes, r lies between 0 and 4, this is 0. Similarly b1 is 0, b2 is 0, b3 is 0, right? Next b4 is also 0, right? How many you will get? How many zeros you have to write here? b0, b1, b2, b3 and b4 also you have to write now. b4 is also equal to 0, right? Now see, there are 5 zeros are there, okay? Next one, when r is equal to 5, r is equal to 5, that means b5 is equal to 2, b6 is equal to 2, b7 is equal to 2, b8 is equal to 2. That means if r lies between 5 and 8, those values are equal to 2. When r lies in between 8 and 10, 8 less than r here, not less than or equal to, less than or equal to 10. That means when r is 9, b9 value is 3, b10 value is 3. Right, when r is greater than 10, that means b11 value, here this r value is greater than 10, therefore 4, next value is also 4, next value is 4, and so on. This is the terms of the sequence. Now here for the sequence we are assigning a symbol a of x is equal to a series in x, that means a power series in x, that is a0 plus a1x plus a2x square plus a3x cube plus so on an power xn. That is means a polynomial in x, a simple polynomial, right? A simple polynomial in x of degree what? Right, it is there is no highest term kada, therefore manam cheppalem ikkada degree anedi, right? It is an infinite series in x, right? Now that is denoted by a of x, which is very very important. This notation is very important. Now here this series we are denoting it by summation r running from 0 to infinity a r x power r, a r x power r. Right, if you remove the summation, again you will get this series only. Now this series is called a formal power series or formal series. A of x is equal to summation r running from 0 to infinity a r x power r is called a formal power series, where ai is the coefficient of xi. See here, what is a1? A1 is the coefficient of x power 1. A2 is the coefficient of x power 2. A3 is the coefficient of x power 3, and so on. An is the coefficient of x power n. Similarly, ai is the coefficient of x power I. Right, the ith term ai power x to the power of I is the term of ith degree. What is the degree of this term? That is 3. Right, now a naught is equal to a naught into x power 0. Here this is called a constant term. This constant term can be written as a naught into x power 0. X power 0 is always equal to 1. Something to the power of 0 is 1, no? That means the constant term is nothing but here a naught, which can be written as a naught x to the power of 0. Right, now here the important thing is, now the formal power series a of x, no, r running from 0 to infinity a r x power is called a generating function. It is the generating function for the sequence a is equal to a r running from 0 to infinity. That means this generating function generate the coefficient of x. Generating function generate the coefficient of x. Those are the terms of the sequence which generates the coefficient of a power series. That is called generating function. Now see, some examples are given to you, some properties. Ax is equal to summation r running from 0 to infinity a r x power r, bx is equal to r running from 0 to infinity b r x power r. Similarly, c of x is another power series, or you can say generating function r running from 0 to infinity c r x power r, or the formal power series. Now two formal power series are said to be equal. A of x is equal to b of x if their coefficients are equal, right? Corresponding coefficients, and x to the power of ith coefficient in the first series is equal to x to the power of I in the coefficient of x power I in the second series. If both are equal, then we can say that the given two series are equal, right? Therefore we can write ax is equal to bx.